We shall implement and simulate our digital logic gates using the PSpice software. So here we will be discussing 7 gates: OR, AND, NOT, so 3 basic gates, and then NAND, NOR, XOR and XNOR, 4 derived gates. So 7 gates we will be discussing in this particular session. So let us go for first one. So here for this 7 gates we require the respective IC numbers. So 7432, that is 2 input quadruple OR gate IC, 7408 and 7411, these 2 ICs are available in the PSpice software. So it is our 2 input quadruple AND gate IC, and this is our 3 input triple AND gate IC, so that is 7411. So NOT gate is 7404, NAND gate is 7400, 2 input quadruple NAND gate IC, 7402, that is the 2 input quadruple NOR gate, and here we are having 7486, that is 2 input quadruple XOR gate. Regarding XNOR gate, we are having one IC, that is 74266 and 74810. Okay, now let us go for the respective logic gates in details. So at first we are starting with this OR gate. This is the OR gate truth table. So we know that in case of OR gate, when any one of the inputs is 1, then output will be 1. When all the inputs are zeros, then output will be 0. This is a respective circuit we have made in PSpice software with this IC 7432, because 7432 is the OR gate IC. So here we are having the ditch stream, here we are having this 7432. This is our if out, that is the digital logic out, and these are the voltage markers we are using. So we require if out, ditch stream and this 7432, and this is the respective timing diagram. So here this is my LSB and this is my MSB. So it has been kept in such a way that we can going to get our 0-0 combination 0-0, 0-1, 1-0 and 1-1. And we know that in case of OR gate, when 0-0 input will be there, output will be 0. When 0-1 or 1-0 or 1-1 inputs will be there, then output will be permanently 1. So in this way, the simulation output has been tested. Let us go for the AND gate. So here the IC number is 7408, and this is the respective truth table for AND gate. We know that when all inputs are 1, then output will be 1, otherwise outputs will be 0. So we require this ditch stream, we require this 7408 IC, we require this if out as the parts name, we are having this voltage marker accordingly. So these are the parts list, and this is the respective output. So here in this case, you see for 00, for 01, for 10, I am getting 0 as output, and for 11, I am getting this 1 as output. So in this way, the simulation output has got tested. So this is our NOT gate. That means when 0 is input, 1 will be the output. When 1 is the input, 0 will be the output. So this is our NOT gate. The IC number is 7404. So I require this ditch stream. Only one piece will be required. And here we are having this if out as a digital output accordingly. So this is a part list, and this is a respective output. So now here you see we have made this A bar. So this is my A. So I have made that one A bar. So when it is low, output is high. When it is high, output is low. So here this B line is not having any connection with this NOT output. So this is my NAND gate. So this is the first derived gate I am going to discuss. We have already covered 3 basic gates, that is AND, OR and NOT. So this is our NAND gate. So here the IC number is 7400. This is the respective NAND gate symbol, and if out is there. And in case of NAND, it is just the opposite of complement of an AND gate. So in case of AND gate, when all inputs are 1, output will be 1, otherwise they will be 0. But in case of NAND, these outputs will be 1 and this output will be 0 accordingly. So the respective IC number is 7400, and we require the ditch stream for the inputs, and this is our if out for the digital output. So this is the respective simulation output. So in case of NAND, for 00 output will be high, for 01 output will be high, for 10 output will be high, and for 11 output will be low. So the simulation output has got tested thoroughly. So this is our NOR gate. So here it is just the complement of OR. So for 0 0 OR will be producing 0 but NOR will produce 1, and for 0 1 1 0 1 1 OR will produce 1, so NOR will produce all zeros. So this is the respective IC number that is sent for 02, and there is a very peculiar pin numbers you can notice in the previous ICs. In the most of the ICs we had in our digital ICs 1 2 input and 3 output, but in case of send for 02 1 will be the output and 2 3 will be the inputs, and in this way other 3 gates will have the IC pin numbers accordingly. So this is the respective parts name required for the construction of the circuit, and this is the respective simulation output. In case of OR 0 0 will produce 0 as output, but here in case of NOR 0 0 will produce 1 as output. So for the 0 0 input 1 is output, and for 0 1 1 0 and 1 1 we are having this 0 output is being continued. So this is our XOR gate. IC number is 7486. So for same inputs output will be 0, and for unequal inputs output will be 1 accordingly. So this is the XOR gate IC, that is the 7486. D stream giving the inputs, if out and voltage level markers are there. This is the parts name, and this is the respective output of this XOR gate. So for 0 0 output will be 0, for 1 1 output will be 0, and for 0 1 and 1 0 output will be high. So we are getting the same. So for 0 1 and 1 0 output will be high in this case. So we have got this XOR gate simulated output. So let us go for the NXOR gate. So this is IC number 7486, and then we are putting this 7404 as the output. So here we are having this because in case of student version of the PSpice software, those IC numbers are not present to construct the NXOR gate directly. So that's why XOR output has been passed through one NOT gate to get the NXOR output accordingly. So in case of NXOR also it is known as equivalence gate. So for the same inputs output will be 1, and for unequal inputs output will be 0 accordingly. Actually the logic is in this way: whenever we are having even number of ones in the input combination, output will be 1. Whenever we are having odd number of 1 in the input combination, output will be 0. So that is actually the basic logic here. So here we are having only 1 1, here we are having only 1 1, so that means we are having odd number of 1s, so output will be 0. Where here we are having 0 number of 1s in the input, here we are having 2 number of 1s in the input, so output is 1 accordingly. So that is the actual logic here. So this is the respective circuit diagram we have made, parts list we have shown. SEN404 is the NOT gate, SEN486 is the XOR gate IC, and this is the respective simulation output. So for 0 0 output will be high, for 1 1 output will be high, for 0 1 and 1 0 output will be low. We have shown that one. So let us go for all the gates in one shot, in one view. Okay, so these are the full parts list if you want to implement all the 7 gates. So in case of this stream, we are having this A and B. The full time period is 2 millisecond. Out of it, 1 millisecond will be high and rest 1 millisecond will be low. Here in case of B, we are having this full time period is 1 millisecond. So 0.5 millisecond will be high and 0.5 millisecond will be low accordingly. So as a result of that, it is having the time period double than this one. So this is the respective circuit diagram for all the gates in one shot. We have discussed them individually in the other slides, and this is the respective output of all the gates in the simulation. So now let us go for one demonstration, practical demonstration, where we shall show you that how these gates can get implemented. At first we are opening one schematic. Control R for rotate. We have taken one ditch stream, 2 ditch streams we have taken. We are going to form the OR gate at first. So 7432 is the IC number. We are taking one AND gate 7408. We are taking one NOT gate 7404. We're taking one NAND gate, 7400 is the IC number. We're taking one NOR gate, 740002 is the IC number, 7402. Going for XOR gate. Taking another XOR, and at the output of the XOR gate we shall put one NOT gate to get the output of NXOR. So this much we have done. Now let me connect the circuits, draw where. We're taking if out. Connecting them with the outputs of the gates. Labeling them. Blank spaces are not allowed in the label. Going for redraw. So now this is the circuit we have made. Now let me set the parameters for this D stream. Here we are going for time and on time. So for A I'm setting 2 millisecond. I'm setting here 2 millisecond. And then 1 millisecond. Applying this one, so the graph is showing accordingly. So this is our 1 millisecond and then 1 millisecond. So 2 millisecond is the time period, and on time is our 1 millisecond. So that is the on time, and time period is 2 millisecond. Now I shall go for, I'm going to save this one, this stream. For time and period and on time, here we are putting 1 millisecond and 0.5 millisecond. Applying this one. So now here we can get the combination like 00, 01, 10 and 11. So I think 2 millisecond is just enough to get all the possible combinations, that is 00, 01, 10 and 11. So within 2 millisecond I can get it. So I'm saving it this one. So I'm going for analysis setup. I can also bring the same window by clicking here, setup analysis. So transient, here the setup time is 0.5 millisecond and this one should be 2 millisecond. Going for OK, going for close. So now this is the setup we have made. So now we shall execute we shall run this software in the simulation mode. Before going for the running, let me put some voltmeters there. So voltage or level marker. Don't forget to put the output levels before putting these voltage markers or level markers. So now let me execute. We can run it from here, simulate, or you can press F11, or you can click here also, that is analysis tab and then simulate option. So this is the simulation output. Now here you see, this is my 0 0, this is my 0 1, 1 0 and 1 1. For 0 0, at first we had our OR gate, so 0, and for the rest cases it is permanently 1. Next was our AND gate, so 0 0, 0 1, 1 0, all of them will produce 0 low, and for 1 1 only it will become high. For NOT gate, you see it is working on this A input, it is working on this A input. Okay, so this is working on the A input. So when A is 0, then this NOT is having the high voltage, and when A is high throughout, then NOT is having the low voltage. So this is my NAND gate, so it will just work opposite to the AND gate. So in case of AND, I had 0 throughout, and at the last I had 1. So here also in case of NAND gate, I shall be having 1 throughout, and at last I shall be having zeros. Then NOR gate we are having, so NOR will work opposite to OR gate. So in case of OR gate, I had this 0 there, and then throughout I was having 1. So in case of NOR gate, I shall be having 1 there, and rest throughout I shall be having my zeros. For XOR, we know that when equal inputs are there, it will become 0. So for 0 0 and for 1 1, it is having 0 value, and for 0 1 and 1 0, it will be having high value. And for NXOR gate, it will be working just opposite to XOR. So whenever XOR was 0, NXOR will be 1. Whenever XOR will be 1, NXOR will be 0, and whenever XOR will be 0, NXOR will be 1 again. So in this way, I have tested my circuit. So I'm coming out. So in this way, the respective circuit can be drawn and can be tested accordingly. And while putting this level marker or voltmeters rather, when you are putting these level markers, then this level marker should be done in this order. If you do this one in this order, then automatically when you will be simulating, the last level marker, whatever you have added, that will be coming at the first, and the first whatever you have added, that is the NXOR gate, that will be coming at the last, at the bottom. So you can maintain that order. So you are getting everything here. So the outputs are obtained, simulated outputs are obtained, circuit has got tested, and in this way we are working with that. We know that 7432 is a quad 2-input OR gate IC. So it is having quad, means it is having 4 gates are there. So one gate will have the inputs like 1 and 2 pin, and output will be at the pin number 3. Second gate, so how to get the second gate? You can click on there. Now this is the respective parameters are there. These are the respective parameters you are getting. So you can click here. So here you are getting 4 options. You can find it. Here you are getting 4 options. So option number A, that is the A gate, means we are having 1 2 input and 3 output. If you go for B gate, that means you are going to get this 4 5 input 6 output. If you double click, if you come to the properties, and please come to the gate here. So now you see, if you make this one C, then you are going to get the other gate in the same IC. So it will become 9 10 input and 8 output accordingly. So the last one can be obtained. If I come to the gate C, then gate D. If you come to the gate D, then I shall be going for the last gate, whatever available in 7432. So in this way, I can have all the gates I can access in this software, just changing the gate name from A to B to C to D in this way. And these things are available for all of them. We know that 7404 is the hex inverter. So we will be having here 6 gates. So come to gate A. Now if you click, you can find that you are having 6 options are there. So A, B, C, D, E, F. In this way, you can change the gate and accordingly the pin numbers will get changed. I think you are getting this logic, how this circuit can be drawn and how the respective simulation can be done and how to change parameters and all. We have shown that one in details to you. Thanks for watching this video.